Hey everyone, good evening and welcome to the JavaScript community, Sri Lanka's first ever meetup. So today's meetup will be discussing microservices design principles and patterns, and it will be conducted by Capstar's very own Sukita Jayasinghe, who is a principal engineer over here at Capstars. So a little bit about Sukita. He has been in the microservices space for about 7 years now. He is currently working on cloud technologies and serverless application development, and is also an AWS certified architect and certified Kubernetes administrator as well. So in today's session, Sukita will be talking about what happened to the microservices hype, communication complexities, and we'll also be covering design principles, patterns, anti-patterns, as well as when you should and when you shouldn't choose microservices for your application. As always, we like to have a very interactive session, so please feel free to drop in your questions in the Q&A box below. And if there's any thoughts that you would like to share with Sukita, you can choose to use the chat box on the side as well for any kinds of communication. We'll also be running a couple of quick polls during the session, so do feel free to join in and interact with us that way as well. So without further ado, Sukita, we'll be happy to pass this on to you for you to take over. The floor is yours.
Thank you. Let me share my screen. Okay, can you enable screen sharing, please?
Yep. There we go. You should be able to share now.
Yeah, thank you very much. So, welcome everyone to the Microservice Tech Talk. I'm Sukita, Principal Engineer at Capstars. So, in this session, we are going to talk about drawbacks of microservice and how we can apply design techniques like design patterns to mitigate those drawbacks. Furthermore, I'm going to talk about what has happened to the microservice trend, how microservice architecture has shaped the tech industry, and how to use and when to use some of the use cases of microservices. So for the final part, I'll do a small demo as well. So let's get started. So this is the Gartner technical hype cycle for 2021. So here you could see that microservice is at the very bottom of the hype cycle. Even if you go and search the Google for tech talks, microservice tech talks are more like 3 to 5 years old. Those content were created when microservice were at the top of the hype. So today microservice is more adapted, it's more matured. So a lot of people have used these microservice techniques for their products. So they have learned the drawbacks and complexities in a hard way. So I believe this is the best time we go and discuss what are these drawbacks and how we can mitigate them, and then take the advantage of microservices by applying those techniques. So this proves the point. This is the architecture design graph for 2022 released by InfoQ. Here you could see that microservice is at the late majority section. So you could see not only microservice, but most of the design techniques or concepts related to microservice is at the late majority. As an example, CQRS, event sourcing, both topics we are going to cover today. And especially you could see that event-driven architecture, it's not necessarily a microservice, but microservice has a lot of event-driven concept included. So we have like domain-driven design. We use domain-driven design and to identify what are microservices. Basically, subdomains are we consider as microservices. Okay. So other than that, you could see that technique like service mesh, it's a technology. So service mesh introduced to address the inter-service communication in microservices. So it's an early majority stage. So you could see correctly built distributed systems also there. So microservices are distributed systems. So this is one of the big topic in microservices. So before we go into microservices, let's talk a little bit about monolithic architecture drawbacks. So here, fundamentally, we have to understand that monolithics are not the counterpart of microservices. It's not necessarily the enemy. We are here not to kill that, okay? So the idea here is monolithic has some drawbacks, and microservice built in a way that it addresses some of these drawbacks. So what we have to do as engineers, as designers, we have to consider these drawbacks from both systems. And not only this, there are like a lot of other design architecture styles like mini service, very popular today. And we have like serverless type of systems, SOA systems, and some hype we can see in modularized monolith as well. So we consider like drawbacks, we consider advantages, then we select carefully what is the style we are going to use. So, and still today, monolith can handle up to 90 to 95% of software requirement we have in the world. So it's a huge number. And let's discuss some of the drawbacks. And basically what happened is most of the time, your situation is that business need required to achieve something, but your architecture doesn't support. That is the point where you go and think whether you need to do some refactoring, apply some best practices to your system. And then if still you are not able to achieve, then consider the moving out from the style and select new type of style like microservices, right? So primarily, the reason of most of the companies moving out of monolithic is scalability related. Not necessarily application level scalability, but also development scalability. Let's take an example. Let's say you have a like huge monolith. Most of the time, these huge monoliths are not properly engineered and spaghetti codes. You want to release a set of features, your business demand to release these features in 2 months. So now you are planning to go and hire freelancers or some the outsourcing company and get like 10, 20 engineers and put them into work and get these features out. But the problem here is these newcomers will take, months reading this code, understanding the logic, and then they will take like months to start producing productive codes. So this is the biggest challenge I see with Microsoft monolithic applications. Here we have another problem requiring long-term commitment to technology stack. I'm not even talk about different framework or different languages. Still, I have seen that in a lot of like companies, there are legacy monolith system. They even can't move into the immediate version because there are a lot of duplicate method and they have to go and change their source code. So huge reluctance come from the middle management and developers not to like move to the next framework. So next version of the framework. So let's see how microservice can address these issues. Before we go into talk more about that, let's talk about the definition. Okay, that's the boring part in any tech talk. But this is the one I like the most. The definition. It says particular way of designing software application as suites of independently deployable services. So it says nothing much about designing, but in order to application to independently deployable, there are a lot of design has to be happen. There are a lot of engineering has to be happen on top of that. So I like this because of that. Let me like read out 1 or 2 definitions. I took this from Amazon Microservice page. It says, microservice is an architectural and organizational approach. That is one of important point. It's not only architectural, but it has like some organizational factor as well. So this I'm going to talk more in a couple of slides. To software development, where software is composed of small independent services. Yeah, it's from the like previous definition as well, that communicate over well-defined APIs, and the services are owned by small self-contained teams. So basically we call these are like 2 pizza size teams, like mostly less than 10. I think 7 to 8 is the like best number. So mostly microservices are belong to this type of small teams, and practically small team can handle up to like 6 to 7 microservices as a good number. So that is one. And then let me read out what is from Wikipedia. It says variety of service-oriented architecture, aka SOA. So SOA was popular around like 10 years back, and then as a success of SOA, the microservice came in, and people call it most opinionated way of SOA style. So arrange an application as a collection of loosely coupled services. Yeah, application has to be loosely coupled in order to independently deployable. In microservice architecture, services are fine-grained, so that is very important part. Your service has to be well-defined. It should have like well-defined tasks to do. And services are fine-grained, and the protocols are lightweight. So let's go and extract some of these properties, and let's talk about them. So properties of microservices, it's highly maintainable and testable. This is not because of the size of the source code. Okay, so microservices are not just because they are like small in size in code base, but they have to be like well defined. The interface between services has to be well defined. Because of that, we can consider these as small units, and it's maintaining these small units are really easy, and then this unit can be like test independently. So the idea is like your entire system can be tested as small units, and then you can run integration testing on top of that. So that's fine. So these are like loosely coupled because of the properties we discussed. These are like loosely coupled. So here I like to go into like OOP best practices a little bit. So in OOP, we say that your classes has to be loosely coupled and high cohesive. This can be like applied to microservice context as well directly. So that means like your component has to be like well defined. The task of the component is well defined, and then it can work independently. So that is the idea. So and again, we discuss about owned by small teams. Yeah, that's fine. And independently deployable, that also fine. So let's go and talk about advantages. So these advantages bind to the properties of the microservice. So it has like improved maintainability because of the size and because of the way we organize it, and better testability that we also discussed. And then better code-based maintainability. Yeah, we discussed that as well. So I like to discuss a little bit about development friendly and ability to adopt new technology faster. So I have worked with a lot of software engineers, and I work with engineers day-to-day lives, and I have seen a lot of demotivated engineers who are working in monolith application, stuck into certain framework, and so they are not actually producing good outputs. But people who work in style like microservice or serverless type of application, they in their day-to-day life, they learn new things, they apply whatever they learn into the into day-to-day life, and they provide like really nice output, and then they create like really cool softwares. So here that's one aspect of it, and other aspect is like there is no huge cognitive workload on the developer, because they can focus on these small components, and they don't have to like keep remember all the like classes structures in the system, and it's really like make their life easy. So fault isolation is one of the fault isolation is one of the important part when it comes to operations. So let me take a small example. Let's say we have like monolithic application, it's order processing application, and we have a mail sending functionality included to that. So the problem is, let's say this function is not tested properly, and this has some memory leaks. So this could bring your system down easily. So still you will not be able to do at least like minimum features on your system, because your system could like go down easily. But if you go to microservices design in the way that it provide core business functionality without interruption. Even though we can design like system even without like core functionality, system still able to function. As an example, let's say I have the ordering system, and my or the delivery part is down because of some problem in the external API, right? But still I can accept orders, still I can take payments, and when my order system is back, my delivery system back, I can go and execute that deliveries and make sure that order is accepted properly. So these are the very important thing when it comes to the designing fault tolerance in microservices. So it depends, highly depends on your business case. You have to talk to business and you have to explain them different use cases, and then they will select the correct sequence, correct path. So let's go and see how microservice has changed the software development process. When we discussing microservice, there are two main factors or two main properties we discuss. One is small team and other one is iterative, incremental, rapid outputs, rapid releases. So these two are the core and these two are like foundation of agile as well. So microservices and agile work smoothly in industry. I have seen that if you want to run your agile process properly, then you have to be in microservice type of architectures. If you are facing any issues when doing like rapid releases, then you might have some problem in your architecture. You should go and revisit your architecture. If your architecture doesn't support that, then your development process might not match your architecture. So you have to like change either one. So when we talking about iterative, incremental, small component deployment, most of the time we are talking about the containerization. Containerization here for decades. I think LCX Linux containers released 2006 or 2008, so some more than like 15 years ago. But microservice created the need to these technologies to emerge and grow into huge ecosystem. If you go to Cloud Native Computer Foundation website, if you go and check what are the containerized technologies available, you will see like overwhelming number of technologies out there. So basically, these are included developer packaging system like Docker, container runtimes, and orchestration tool like Kubernetes, and then some utilities like container registry, service discovery related containers, and so on and so forth, right? So that's mainly this containerization and rapid deployment and partial deployment created new vertical, new vacuum where DevOps come and placed. So DevOps is mainly set of automations, and it has like CI/CD. I'm huge fan of CI/CD. So CI/CD is there, and then a lot of automation is there. So this is the foundation of DevOps. And in order to debug and trace these kind of distributed systems, it need a lot of observability, traceability included. So these techniques are built in DevOps space. So let's go and see what are the drawbacks. So this is the place where we have to be very careful, because people go and apply microservice without thinking these drawbacks. So microservice has the additional complexity inherited being distributed system. So distributed system are running on networks. Networks are the really bad place to be. It's really dangerous place to be, because these networks create delays, partial failures, partial network isolations, and then inconsistent in communication. So I've seen that 70 to 75% of problems in microservices converge into the network related issues. So it's really difficult to address these kind of issues, because mostly these are like two different teams. And I have seen this become like really ugly ball passing game where network team point to the developers and developers start pointing to the network teams. So our responsibility here is understand that we are working on distributed system, we are working on networks. So networks are not reliable. So we have to address these delays, failures, partial failures, and retries we have to implement in our system. So that is the most important thing we have to understand. Then deployment complexity in the production. I have experienced this really bad way when we wanted to once we wanted to convert whatever the existing monolith application into a distributed application like more microservice. Then what we found is after 1 year of development that our operational team is not capable of running these components. So we have to parallelly work on our operational teams, our DevOps team, site reliable engineers, and make sure that they learn whatever the components we are going to use. They do lot of trial deployments, and then they are ready to work with the software we are building. So if we don't do that, then we fail really bad. So that's one thing. And then increase resource consumption. This also I have experienced really bad way. We had a distributed monolith type of application. These are really bad to have distributed monoliths because they still have the communication complexity, but it's not providing the advantage we have in microservices. So we thought we are going to break down this, and we are going to apply design techniques and make it more a nice microservice system. So the problem was this distributed monolith application were run in 4 machines with redundancy. But after 1 year of development, we found that this distributed this microservice application require around 16 servers to run with all the clients compliance to comply to their compliance. So the problem here is normally when we go into microservices, we use messaging platform. So these messaging platforms like Kafka or RabbitMQ need at least 3 servers to run in a cluster. So when we are moving to microservices, the trend is we move into NoSQL databases as well. As an example, in order to manage state out of your services, make services are more stateless, we use Redis as a distributed state store. So Redis require at least 3 machines to build proper Sentinel cluster. So that is something adding up to your resource requirement. And then again, in order to run your application, your containers, you need some orchestration platform. Let's assume you are going to use Kubernetes. Then Kubernetes need at least 3 controllers in control plane to run their control plane containers, and then they need at least 3 machines to run their workloads. So if you already have customers, if you're planning to move to microservices, then you better go and talk to them and better see whether they have the infrastructure you need. The problem is if they don't have, then it's a huge process. They have to go and take the board approvals, and then they have to go and place new racks, ACs, power, and then place new servers. Then this might take years and a lot of cost involved into that. So this is these are main drawbacks of microservices. So let's talk about microservice communications part. So this is I think you already have seen this. This is from Netflix. You could see that how many communication between these small microservices. So, and one point here, a lot of people impressed by cases like Uber, Netflix, Twitter, Facebook, and directly copy this architecture and apply into their softwares. But Netflix, this is good for Netflix because Netflix they run 500,000 containers per day and 200 clusters per day, and this kind of architecture is good for them, but might not be suitable for our use cases. So if you are doing architecturing, you have to consider your non-functional requirement mainly, and then design your design your architecture to match these requirements. So still we can, go and learn a lot of things from these giants, and then we can, use whatever their techniques which suitable to our use cases. So if we talk more about microservice communication, there are like two types of communication. One is north-south traffic and other one is east-west traffic. If you take north-south traffic, that is mainly traffic coming into the system and traffic going out of the system. So these in the Kubernetes world, we call these are like ingress and egresses. So these are like mostly coming through API gateways, and these are more standard HTTP protocols like REST, gRPC, or GraphQL. So if we talk more about north-south traffic, we have to talk about API management, API security, API versioning, throttling, and staging, and those kind of things. So I'm not going to like spend much on this, and let me like go and talk about east-west traffic, which is more relevant to today's discussion, and mostly asynchronous communication. Like synchronous communication is very rare in inter-service communication. So if I go and take the asynchronous communication, there are two models. One is polling and pushing. So polling means like your client go and talk to the messaging broker and give some reference point. Okay, give me number like messages after this particular reference point. So this is more intelligent client and dumb broker type of communication. So Kafka and SQS are more polling type of messaging queue. So advantage here is your service could go and start picking messages when they are ready to process based on like your resource availability. You can go and poll. And pushing, other hand, is sending messages like whatever the latest messages through a persistent connection to the client end. So I prefer like polling the most because of the higher scalability nature of the queue platform. So when you're selecting your messaging platform, you have to think about a lot of parameters and a lot of properties of the queuing platform. There are like overwhelming number of queuing platforms out there. As an example, Kafka, RabbitMQ, ActiveMQ, ZeroMQ, SQS, SNS, Redis. If you go to GCP, you will see like topics. So this list keep going and going. So when you are selecting whatever the like messaging platform for you, there are like mainly two properties you have to look into. One is message delivery reliability. So there are three types of message reliabilities. One is exactly one type of delivery. Kafka is that kind of queue platform, and then at least one and at most one. So RabbitMQ and Redis are into this at least and at most one type of delivery. So here you have to build your application to support these kind of deliveries. As an example, let's say our queue platform is at most one. So that means there could be like message losses. So in your system, you have to build retrying and acknowledgement into the system. And let's say if your system is at least one type of system, that means like you might get duplicates. Either you have to build your logic to support duplicates, or you have to make your system idempotent where service keep track of whatever the like processed events, and then make sure that you are like handling these duplicates and not letting them through the system. So another thing is order of message receiving. So Kafka allow you to have this property, the proper order, because Kafka is more like log trail type of system where you have like trail where you go and add your new events at the bottom of the trail. So when you are reading, you read like in a proper order. But the other system like RabbitMQ doesn't provide that type of ordering. So then in your application, you have to go and build reordering before you go and process. You have to build your own sequencing system, and then application has to check the sequence. And if sequence is not correct, it has to wait and collect other events and make sure that order is applied before it go and process. So here I have small microservice diagram, and we are going to use this to discuss some of the issues and then design patterns. So here I have API gateway and at the top. So this API gateway help to aggregate services and give nice output to the external party. So I have like two methods. One is place an order, get order status. So this is a CQRS type of pattern where you have place an order to order service and get status in the status service. And you can see that asynchronous communication, which represent the queuing system. And again, you can see order, payment, and delivery. So they have their own databases. So here we have to understand the concept of ownership of data. So each service should own their data set. So as an example, let's say another service like delivery service want to go and access order data across the context of the system. It has to go and talk to the order service and should not go and directly access order DB. So this is kind of like nice, and this is the standard way, and we should follow that. But there's a huge problem generated by this. That is, if you take relational database here for very long time, and they have matured into this stage with a lot of effort, a lot of academic works, and a lot of experience. So they provide you nice consistency and integrity to your data. So as an example, it provides you the main feature that they provide you is the ACID transaction. So ACID means atomicity, consistency, isolation, and durability. So if one statement fails, the entire transaction can be rolled back. So you don't have to do anything manually. And this type of system, you will not get that. So you have to go and implement the rollback process your own. And that is the huge disadvantage I see. And there are other things. As an example, let's say Mike's relational database provide you cascade deleting, and which you will not get here. And again, it will not allow you to delete records which reference as foreign keys. So here you don't have that. So you have to like carefully build all those things. So this is huge overhead, but let's see how we can address these issues. So what are the patterns can help us to address this issue? Mainly Saga pattern can help us here. So what is Saga? There are like two types of Saga. One is choreography and other one is orchestration. Choreography is more like system fire, it's domain event, like let's say order file events like order accepted, and payment fire event like payment received, or delivery fire event like delivery started, something like that. So these are like more domain driven events. So other applications should have enough intelligence to understand these domain events fired by other services and then process accordingly. And then orchestration is more centralized, where you have Saga in a single service, and it keeps this domain status in its local database and make sure it run the sequence, it's run the process. So let's go and talk more about choreography. So here you could see that the scenario here is order system want to get some payment done. So instead of order go and ask payment to do certain actions, it go and fire that order is in place. So payment listens to that and read the event, and then it understand, okay, now order is placed, now I have to do the payment part. So it goes and do the payment part and store that in their local database. So then it fires the like order is reserved. Then order is listen to that topic and then read the event and find out that, okay, payment is done, now I can approve the order. That is the basically natural way of how microservice works. If you already have built distributed transaction, this should be the way you have implemented it. So it's decentralized and it's scalable due to event-driven nature. And but the problem here is, if you want to understand the full logic, you have to go and read all the like services source code, because it's not in a single place, and debugging this type of system is really difficult. So you have to place additional instrument like distributed tracing. So you go and read the traces and then identify where the issue has happened. So that's basically choreography, and orchestration has like more advantages. The idea here is, like, even though these two diagrams look similar, it's completely different in messaging pattern. So there is like order saga, domain object with status stored in local database of order. And what it does is, it's go and request payment to do some action, and it wait in the reply. And this is more request and reply type model instead of firing just domain events. And these are like more like workflows, and just don't confuse with BPMs. These are not BPMs, but these are like millisecond or seconds size of workflows. So still you can use things like step function or GCP workflow to implement this pattern, or even you can code it yourself. But there are like cons in this system. The main disadvantage is this can lead into monolith orchestration anti-pattern. So this anti-pattern I've seen even in like bigger companies here, because you go and build all your logic into this saga. So the saga become a god service, and all the other small services become dumb services, just utility services. And that is not we are expecting from microservices. So these are like two ends, and one end you see that some coupling, because you are firing domain events and all the services need to know other services domain event. So that's kind of a coupling, and that also bad. And this end we can see that monolith god service type of anti-pattern. So you have to carefully select what you want and make sure that service has enough intelligence and service not become a control of all the other services. So this pattern has one drawback, that is, here we want to atomically update your local database and go and send the message. So assume that order service just go and write the order entity and then try to send the message, but failed due to unavailability of network or something. So now you are in inconsistent state. So roll back this kind of inconsistent state is really difficult. So these are like rare, but could happen. So when it happen, it give you like really bad experience. Okay. So there's one pattern which can help us to achieve this. The pattern is event sourcing microservice pattern. Instead of storing the whole domain object with the current state, here we go and record every state change, every event in the state change. So the advantage of this pattern is this provide really nice audit trail, and it preserve the history. Let's say like you have you had some problem in your calculation, you want to rerun everything and create the final object. So still you can, because you have all the status saved nicely. So you can go and replay. You can go and update whatever the service which had faults, and then you can go and replay this and create the final object with proper states. So this provide you single source of truth. So here, this force you to apply another design pattern, that is CQRS, command query responsibility segregation. Why we need that? Because you don't have a single object with the current state. So you want to like run some complex query here, and you want to like read all these things and build the output, something like meaningful, something useful to the outside by using another service. So this forces you to use CQRS pattern. So we'll talk about CQRS pattern. Before we go into that, I like to talk about outbox microservice pattern. So outbox microservice pattern is something address the same issue addressed by event sourcing microservice pattern, but I see this pattern as nice initial point of your microservice migration. Let's say you have a monolith system, you want to go and start building microservices on top of that. Now you don't want to touch the main system. You are afraid that might that might become unstable. So what this pattern does is there are like tools like Debezium, where you run this Debezium connector go and connect to the database, and it go and read the val or bin. Val means like write ahead log in progress. That is the transaction log database, where you go and listen to that, or if you are using MySQL, that's bin. And then it read the changes of the database, and it can, without any additional code, it can take these changes and publish into a Kafka. So now you have nice Kafka topic which has all these database changes. So you could go and build a microservice. Let's say you want to build a reporting system on top of this. That microservice can read from this topic without interact with main system and start building features. So this is really nice pattern if you're planning to move onto like microservices, and you can experience, you can try things out without affecting to the main system. So that's it. So okay, let me like explain a little bit about how this works and in normal context, right? So you go and create a transaction, and then inside that transaction you go and write to the domain table, and you go and write to the outbox table in same transaction. So it's atomic. The writing and sending message is atomic here. So that is the main idea. So today this is the last design pattern we are talking about. So CQRS microservice pattern is very common microservice pattern. Microservice enable polyglot in language, framework, and so on. But CQRS provide you the database polyglot. So today, one database will not allow you to do all your not provide you like all your database requirements. As an example, let's say I want to search my order. So normal like query or normal relational database will not help me much on this case. So I want to have Elasticsearch database where I have nice integers there. So I create separate services to go and search from there in Elasticsearch. So the whole idea here is we can use whatever database we want, and the second thing is service scalability. Let's think you have like less read and more write type of system, or less write and more read type of system. Then you can scale your databases, you can scale your services based on your demand, your requirement, so without affecting to others. There's one challenge here, that is replication lag, because your data might not available instantly in search system. So you have to make sure that you build your user experience, maybe front ends, to address this type of issues. So, and it's all I have in my presentation. Let's go to the demo. So here I tried to implement the three design patterns. One is at the top, you could see that I have CQRS. I have like three services. One is order service, order state service, and order history service, where request is coming to the order service, which is write database. And when you write to that, that message will pass it to the order. So I have the Saga pattern here. You could see that here I have order Saga. In order Saga, I could see that you could see that this is more centralized Saga. You have payment and delivery. If order want to go and order want to do some change in the payment, it go and request payment to do certain payment reduction, and it go and reply back in a reply topic with payment is reserved. Then Saga go and request order system to go and do the Saga system go and talk to the delivery and ask, okay, initiate the delivery, and then it get the reply like that. So here you could see the Saga pattern, and at the left side here you could see that I have DBSIM connector connected to my OrderDB val, and then I read it from there and I try to push it to the status topic, and where I have the status service, read all these things and generate the history, and you have history service which read it from there. So let me go to the source code. Okay, hope you're able to see my source code. Right, great. And here I have a Docker Compose file which helped me to launch the entire system. And here I have my own set of services, and I have third-party components like Redis for caching, Postgres, and I have like Zookeeper, Kafka combination here. I have like DBSIM connector. Then I have these are like utilities in order to go and check the system. And let me go to the order Saga here, and you could see here the Docker file which helped me to containerize my application. And if you remember the pattern, basically order handler first listen to the order queue, and then it listen to reply queues. So when order request comes in, it go and process the order, and then it goes and store the domain object, and then it goes and fire an event to the queue payment. Then once queue payment process the payment, it will reply. So we listens here, the service listens here to the payment reply, and once the payment is processed, we go and check the payment, and then the service fires the delivery event. So once delivery is successful, it goes and fire the delivery reply. So here I try to implement the reconciliation process. So I go and check whether a delivery is failed, then I start the reconciliation. I go and ask payment, okay, the operation failed, now you start the rollback, undo whatever you have done. And then if it is success, then yeah, order is processed and we continue. So that's the basic design here. So this is the advantage of centralized Saga. You could see the whole logic for here in a single code. And I just want to show you another. Yeah, here you could see that this is the status service which listening to the Postgres public events which fire from DBSIM, and then it go and creates the history, so which reads from service history. So this is how I organize the source, and let me run the system. I hope you could see the terminal. So let's go and see whether there are any containers running. No. So let me go and turn on the system docker compose up. So this should turn on all my containers. Here you can see that it's loading all these containers and start running. Okay, I can see some error. Okay, maybe that's fine. We'll like restart it and see. So maybe I run this few times and try a few things here, and so I might have done something foolish. Okay, it seems like it takes like few more seconds to start everything. Yeah, it almost up. Yeah, let me go and see whether my Dockers are up and running. Yeah, I can see all of them are up and running. Now I have a set of collection here. First, I have a Debussy connector configuration here. So maybe it might already, yeah. Now I created the connector. What this says is, okay, you have this database, go and listen to this database, collect whatever you have, then go and publish it to the Kafka. So this is the configuration of Debussy. Then I have service request to initiate the order process. So here you could see the style that immediately it will return you the transaction ID. It will not wait until everything complete. So it will give you flexibility to implement the user interfaces the way you want. So this is the transaction ID. Now you can see here it's connected to port 3000, which is running the service. And then if you want to go and get status, you have to give the transaction ID. And if you execute that, you will see what is the current status. Yeah, order is processed. And then I'm not sure whether this will work because I saw some errors there. Let me try out. Yeah, it worked. And here, this is the history of our transaction. You can see here it's accepted, payment processed, delivery processed, and order processed. So it gives you like nice view of the transaction. And I have used like 200 item ID to simulate the failure process. So this is the transaction ID. If you go to the status, let me like replace here. Yeah, okay, this order failed. Yeah, then let me go and show you what has happened in our event-driven system. Here you can see that first it's accepted, then payment processed, and then delivery get failed, and then reconciliation started, rollback process started, and then payment reversed and order failed. So this is all what I have today. So thank you, everyone. Let's go to the Q&A session.
Thanks, Sukita. So we do actually have quite a number of questions that have come in. So I think we'll take maybe the next 5 minutes to just run through some of these questions. Right. So one of the questions is, could you please explain a little bit about the importance of domain-driven design in microservices?
So basically, we use domain-driven design, and mostly subdomains of domain-driven design is applied into microservices. So microservice is mostly the subdomain. So it helps us to clearly identify what is the business case, and then design the service, a microservice. So I think I answered the question.
Okay. And another question is, and I think it's a question directly to you, Sukita. Will you be sharing the source code which you demoed?
Yeah, sure, I will. It's in the Git, and it's yeah, basically it's in the Git, and I'll share the URL here. Okay, give me a second. I have, yeah, this is the Let me copy this and paste here.
In the meantime, guys, if there are any other topics that you would like us to cover in future sessions, do feel free to just log them into the chat box so that we will be able to have an idea of what else you would like to hear from us. But yeah, do feel free to share your thoughts. The next question is it a good idea to start your project with microservices from the beginning in monolithic?
Okay, basically, if you have good understanding about your business domain, then you can go and start with microservices or whatever the architecture you want. But if you don't have good understanding, if you are in startup, then I suggest go and first build the system in monolith, and then get the feedback, create the feedback loop, get the idea what exactly customer wants. Then from there you can go into the domain driven, as like in the previous question. Then you can understand exactly what architecture you want. So don't go into the microservice architecture at the first point as start, because it need lot of resources, not necessarily from a computer resource, but other skills like DevOps and SREs, and it has like a lot of overhead to start with.
All right. The next question is, what about the cost factor when moving into microservices?
Yeah, it's the thing is, like, if you're moving to microservices, you need to place a lot of instruments, like distributed tracing, and you need like a lot of servers and a lot of computer resources, and you need entire DevOps department. If you have like, if you are going to plan to take managed services, that's fine, because you pay as you go. But if you're going to have like data centers, or if you're going to have a lot of additional resources you are going to take, then yeah, it will double the cost, and there's a lot of time you have to waste debugging and designing these things. So there's like both time cost as well.
All right. Just came to my attention that the chat was previously disabled. So I've now enabled the chat for the audience to put in their comments and their thoughts as well on topics that you guys would like to hear from us in the future. So do feel free to just log them into the chat box. And moving on to the next question. Quite an interesting one, because this session is on microservices, and those of you who watched our last episode of Explorer series, we actually did cover serverless architecture and technologies. So this question is, what's the difference between microservices and serverless?
So serverless is basically you go and commit to kind of a cloud provider. So serverless means like there are still servers, there are still like microservices there, but you don't have access to the servers. So you just write function code. Still, your function code will run in containers in Google or in AWS. Right? So the only thing is they hide you the technology. So it's managed. So you don't have to worry much about all the things like blogging systems in place, all the scalability, and then how you provision, how you scale, but they do it themselves. You do only the coding part. You focus more on your business logic. That is the main difference between serverless and the microservices.
All right. Next up, we have, what do you mean by scaling the application? What do you mean by saying that scaling the application is difficult in a monolith? You had mentioned it in your second slide.
Yeah. There are like two type of scalability issues. One is mainly it's difficult to scale your development team. I have seen like people in monolithic application working there in like maybe 10 years, but like take new set of developers and scale your team is quite difficult, because they take like a lot of time to understand the code, and they are even not like to stay in working in this type of system. So first thing is scalability in the development. The second thing is application scalability. The problem here is, if you build the system in microservice way, then you can scale all these services individually. So you don't have to scale the whole system. Like as an example, let's say you want to, in my particular example, let's say you have like a lot of reads in history, orders history. So you can independently scale that part. If your system is monolith, then you have to scale the whole system. So that is the main problem. Still, you can have load balancers at the top, and you can provision multiple machines, but infrastructure doesn't support that. So you have to go and place machines and do that. So that's the main problem in the scalability.
The next question is it good to use a service like RabbitMQ for prototyping and use Kafka or AWS Event Bridge for the actual product?
So the problem here is, I have used Kafka. The problem of Kafka is early version of Kafka needs Zookeeper to keep their status and to do the lead selection process. So Kafka need a lot of memory, a lot of resources there. So I say, like, if you are going to have like less than 100 messages per second, then don't go for Kafka. It's too big, it's overkill. So go for like something small. RabbitMQ is good option for that. It is written in Erlang, and it provide you the federation nicely, and then it's small in size. So I prefer to go there. But the problem here is, you have to, like, if you are going for scale, if you build your system in RabbitMQ, and if you try to migrate it to Kafka, then your service already built to support the properties of the RabbitMQ, but you need some additional effort to go and support it to the Kafka. And here Event Bridge is totally different. It is to, like, connect to external systems. So I think the best approach is Kafka or either SQS. So those are like similar, but Event Bridge is like something a little bit out of this context.
Right. The next one is, what's your approach towards moving a properly architectured monolith into microservices?
So basically what I say, just go and sit and see whether you have applied best practices into your monolith system. Whether you have, whether like concepts like develop for interfaces rather than implementation type of things. So then what you can do is go and apply those patterns, do some refactoring, and that will really help you. That will not waste your time. So then you can slowly make this modularized monolith. So if this is modularized monolith, then the thing is, still, if you can't achieve what you want, then these modules or these interfaces you can break, and you can deploy these as separate services. You can use strangle fig type of pattern, where still you have your monolith, and you can keep building your microservices separately. So that will not harm the stability of the system.
All right. We have a question that has come in saying, regarding your repo, asking, they could not clone the repository. Are you sure it's an open repo?
Yeah, it is. Okay. Let me check a little bit. Give me a second.
Sure. In the meantime, I see some pretty interesting topics popping up for our next couple of sessions. Micro frontend seems to be quite popular. I got a request for that a little while ago as well. Shamir, not sure if you had mentioned that in the Q&A also, but that is definitely an interesting topic for us to look at. And distributed databases, NoSQL versus SQL, master versus masterless, and quorums. Sounds pretty cool. So we will let you guys know what's cooking in the next couple of installments that we have. In the meantime, do feel free to drop in any other suggestions that you may have as well. Take part in the poll if you haven't already. And in addition to that, we will be taking maybe a couple more questions as well, even though we've run a bit over time. But yeah, do drop your questions into the Q&A box as well. Sukita, all good on your side?
Yeah, it's public, and please let me post the the URL directly instead of my SSH command. Okay, just try to access this. It's public. You should be able to access.
Just posted it in the chat. You can check out that repo and see if everything works well there. Someone has actually mentioned that, yes, this works a little bit better.
Okay.
Cool. Let's jump back into our Q&A. And we've got quite a number. We've got about 12 more questions that have popped up. But in the interest of time, let's take as many as we can within the next 5 minutes. The next question is, what's your opinion on service-oriented architecture and microservices? Is it the same or different?
So microservice architecture, we call it opinionated SOA model. So it's a SOA model. So it's like successor of the SOA. It's similar, but it's more opinionated. So they are like standards, and there are like ways to build the microservices. So still, it's a SOA.
Okay. How do you make the microservices fault tolerant from your experience?
So the thing is, you have to talk with the business and see what are the like crucial services. So you have to make sure that your system runs the way that it support the core business functionalities. If you want to like individually make it fault tolerant, the concept here is you are going to Dockers, right? Docker support restart, and container orchestration make sure that your containers is always running. So you don't have to worry like much. If your container is going to fail, let it fail, and make sure that your services are stateless. So now state goes down with your container. So keep the status out and make sure that your whenever like new container come up, that should be able to continue from that point. So if you build that way, you don't have to worry. So the infrastructure, the Kubernetes infrastructure will make sure that you are like, fault tolerant in a single service way.
All righty. We have another question that's coming, which I think is a little bit similar to one that you answered a little while ago, which is, can you combine and use microservices together with serverless?
So basically, yes, like the system I'm currently working, it has like nice use case, because some of the cases we need to provide additional resource to the microservice. As an example, in my current project, I'm doing a lot of video processing. So I can't do it in serverless because I have to like assign a set of resource to that and GPU to that, and I have to make sure that it is running until everything ends. Serverless mean like you can't run like state based like models there, and there are like time limitation always with the stateless systems. So here I have like Kubernetes platform running, and I have my containers are there. So those are like microservices. So it's totally possible.
All right. And the last question that we will be taking today is, these days there are some openings for microservices developers. Can you explain the roadmap to achieve it?
Can you repeat it?
What is the roadmap towards achieving, towards becoming a microservices developer?
Okay, so the thing is to be there's no something like microservice developer. So developers with microservice handling skills. So you have to first go and look into the some tech talks and go and read about the microservice, especially some sites like microservice.io. If you go there and if you read that, you will understand a lot of patterns, a lot of thinking behind that. So other thing is you can go and check different repositories, and you can check how people have implemented microservices. So there are like open resource like repositories available. Go and check them, read them, and mostly like cover your concepts, and then it's like go and make your hands dirty, build your own system, build your do a side project, build your own microservice platform, and see, experience it, and that will you will learn it hard way, and you will never forget it.
Super. Thanks so much, Sukita. And thank you everyone for joining today's session and for sending all your questions in as well. We've got some pretty good recommendations on following topics for the upcoming sessions as well that have been logged in. So thank you so much for sharing your feedback. Glad to have had you guys all here for the first ever meetup of the JavaScript community Sri Lanka. You can also join our group on meetup.com. Let me quickly drop in the link here for you all to join. So you guys can all join that meetup to stay updated on the upcoming topics, on the upcoming sessions and meetups that we will be having. Hopefully, once the situation gets better, we'll be moving towards physical meetups. Hopefully, sometime in the future. Until then, we'll be meeting virtually. Thank you, Sukita. I'm pretty sure that everyone really enjoyed the session, and there's a lot of great feedback coming in. Really grateful for all you guys joining in. Really grateful for Sukita conducting the session as well today. Do stay tuned for what's coming up next. Follow GapStars on LinkedIn and on Facebook as well to stay updated, and do join our community. Until next time, guys, we will be bidding you adieu. So have a good night and have a good week and a good weekend ahead. See you, everyone.
See you, everyone.